Hello everyone, welcome to NG's Corner for Nurses. Hope all of you are doing well. In last video, we have already discussed about the concept of water seal drainage along with related anatomy and physiology, and also the purposes, indications and principles of water seal drainage. And then we discussed about the different sizes of chest tubes and the site of drainage tube insertion. Let's see today's video. Today in this video we will discuss about the function of chest drain. Next, the types of water seal drainage system which include 1 bottle, 2 bottle and 3 bottle drainage system. Then the modern system, that is the analog multi-chamber system. And then we will discuss about the another advanced technology, that is the dry suction drainage system. And the last topic of today's video is the comparison between wet and dry suction system. Let's discuss the function of chest drain. After the insertion of chest tube, following inspiration, there is increasing intrapleural pressure. As we discussed before, the normal intrapleural pressure is negative. If air or fluid enters the pleural space, then the interpleural pressure becomes positive. This pressure makes the air and fluid move into the drainage bottle. This is because the intrapleural pressure is greater than plus 2 centimeter of water. So, once the air and fluid moves into the drainage, the intrapleural space becomes negative again, and hence the lungs can re-expand to the normal. We will start the types of water seal drainage system with the one bottle system. The bottle or chamber, this one bottle or chamber serves as a fluid collector and a water seal. During inspiration, fluid in the chamber ascends, and during expiration, fluid in the chamber descends. The drainage tube is submerged 2 cm below the level of sterile water or saline, which acts as an underwater seal. An exit vent allows the escape of pleural air to the atmosphere, that is the tube to atmosphere. And this system is used if the patient has very little fluid in intrathoracic space or in case of pneumothorax. In this picture we can see there are a tube from patient and a exit vent, that is the tube to atmosphere, and the drainage tube is submerged 2 cm below the level of the water. Next, coming to the 2 bottle water seal drainage system. In this 2 bottle system, the first bottle, which is connected to the patient, being a drainage collection chamber, that is the collection chamber, and the second bottle acting as an underwater seal, that is the water sealed chamber. However, the collection chamber increases the pleural dead space. What is pleural dead space? Dead space is constituted by air which does not participate in diffusion, that is air present in nose, trachea and bronchial tree, and normally it is about 150 ml. It impedes the re-expansion of lung and adds an extreme amount of work required to expel the pleural collection. Next, coming to the 3 bottle water seal drainage system. When the gravity is not enough and the respiration is too weak and a constant negative pressure is desired, a third bottle is added, which is known as the suction control bottle, and it is added between the water seal chamber and the suction machine. An outlet connected to the suction device and a control tube, which is open to the atmosphere at one end but immersed approximately 20 centimeter underwater at the other end. The distance below water is equal to the pressure generated when suction is applied. Usually minus 15 to minus 20 centimeter of water pressure is used for adults, and the continuous bubbling occurs in the third bottle, resulting in noise. Next, coming to the modern system, that is analog multi-chamber system. Analog chest drainage system combines all these functions that already we have discussed in last 3 slides all together in a plastic housing. The next step in the evolution of chest drainage system was the development of dry suction control chambers. There are various advantages in dry suction water seal drainage, like higher suction pressure levels can be achieved, setup is easy, and there is no fluid evaporated, which would decrease the amount of suction applied to the patient. And instead of regulating the levels of suction with a column of water, the dry suction units are controlled by a self-compensating regulator. And the suction can be set minus 10, minus 20, minus 30 or minus 40 centimeter of water. The unit is usually preset at minus 20 centimeter of water when opened. Both the wet suction system and dry suction system serve the same purpose: to remove air, fluid or blood from the pleural space and to prevent these substances from returning to the chest. Let's see the comparison between the wet suction and dry suction system. Wet suction uses a column of water to regulate negative pressure, whereas the dry suction uses a mechanical regulator. The wet suction systems require frequent monitoring of water levels due to evaporation, but in the dry suction systems are self-regulating and generally quieter and faster to set up. In wet suction system, gentle bubbling in the suction control indicates that the suction is working, and the dry suction system is silent and any bubbling indicates a leak. Last part of this topic will coming soon. If this video is useful for you, then it is requested to put a like and share it with others. And for getting more videos like this, you can subscribe my YouTube channel or follow my Facebook page NG's Corner for Nurses. And for any queries or suggestions, you are most welcome to comment. Thank you for listening.